Welcome back to Odyssey Code. So today what we'll be covering is an introduction to classes. So before we talked about the tools that we'll be using, Java, IntelliJ, Scala, and Swagger, and a few others, for example, Maven. And I thought it would be a good idea for us to start at a very basic level and get an understanding of the types that we interact with in Java and what exactly are types and why we have types, and try to build and ask a very complex question. So let's get to it. So we'll see what we'll be able to implement today. But what I would like for us to do is kind of start off the discussion talking about the base way that we can represent data in Java. And then after that, use that data, that way of representing data to talk about classes and objects after we have a fundamental understanding of the base types. So the first thing we need to understand is that Java is an object-oriented language. And what I mean by that is there are usually different flavors or paradigms of object-oriented languages. And one example of this is object-oriented. And another example is functional. So different languages fall under this bubble. So for us, for example, if we were to list some examples of object-oriented, Java would be one, Python, Ruby, C++ even. Some functional languages, one functional language I really enjoy is OCaml. And we'll talk about other functional languages, but I like OCaml for what it does and how you can define your own types in that language. So at some point, we might even talk about that, and I can list others. But I can. And the interesting thing is, you can sort of. So depending on how you use a language, you can sort of use it functionally and have a higher order procedure. So you could technically put Python here, and you could. And this is really interesting. You can kind of put Java here, but not really. Because what happened a while ago was that Java started off as an object-oriented language, and it dealt with objects. And I'll define what an object is. An object is a way of encapsulating data, right? Data and actions you can take on that data, but we'll have to create a more verbose definition later. Just because when we talk about encapsulation, one needs to talk about object-oriented principles, as well as, like, for example, abstraction, because objects can be used to abstract data, and encapsulation, how you can essentially create an object. For example, a cat that only does or have cat features and things, right? You don't want a dog meowing, right? And you don't want a dog to have access to catnip, for example, right? So how do you maintain that access block? So that's what we mean by encapsulating data. So that's where we'll leave objects for now, but yeah, and we'll leave the object-oriented and functional language discussion as well. But I wanted to introduce those key terms for us to better understand what we mean by object-oriented, and also to introduce the fact that there are different paradigms. So in Java and other languages, you have things called types. And types, right now, we'll just say they are a way of representing data in the language, or in the language of choice. So that's a very high level definition of what a type is. And since we're working in Java, what we'll do is cover the base types of Java. So Java has a few different types, and they each represent different kinds of data and different amounts of data. For example, we have bytes, which essentially represent are a way to represent numbers from -128 to 127. After bytes, we have shorts, which are a bit larger, and they can go from, let's say, I believe it's -32,768 to 32,767, because it's -1. And in order to understand why it's -1, and also the next ways of representing numbers, we'll need to talk about something called 2's complement, which is how computers, which is a technique for how computers represent large numbers. But for purposes of this discussion, we'll just talk about the basic types and their ranges. After that, we have integers, which you'll see quite a bit. And for integers, they're a lot bigger because of how they're stored in memory. So each of these essentially take up a larger chunk of memory. And what we mean by that is a computer is just like a human being, they're very limited in the amount of information they can deal with, store with. And you need to, and for computers, you need to specify a specific chunk of memory for that value. So for bytes, the reason the range is so small is because the amount of allocated memory for a byte is smaller than it is for short, and smaller than it is for an integer. So for integers, we go from -2 to the 31 to -2 to the 31. So I'm going to put a parenthesis here, or no, to the positive parenthesis 2 to the 31 -1. And then we have longs, which are a bit longer than shorts, and they go from 2 to the 63rd to the 63rd -1, and then there's a negative here, I believe. And then after that, we have floats. For purposes of the discussion, we'll just say this is a way of representing decimals. And then you have doubles, which are also the same thing. But if you want precision, if you want precision, what you'll want to do is use doubles because they're more precise. So you would use currencies. For example, we would use this for currency. So this is more for precision, right? Because what ends up happening for integers, if you have 1.50 and 1.50, so when you do that addition and you convert 1.5 to an integer, let's do the integer representation. If you do 1.50 plus 1.50, what will happen, I believe I'll go to the floor or the ceiling. So let's go to 1.2 and 1.2 for now, because I need to verify whether we do floor or ceiling. What will end up happening in some cases is you get 2, which doesn't make sense. But what integers can't really represent decimal values. So for doubles, especially and this is especially true for division. So if you're ever in a situation where you have like a decimal value and then you divide it by an integer, if you're not careful, it can be converted into an integer, or you can lose a lot of precision that way. So if you're going to be doing things like division, use doubles. It's a bit safer, unless you know you're always going to be using integers and they're always going to become whole numbers, because you can end up cutting the decimal off. And if you use doubles, this becomes $2.40. Right. So you see, you lose 40 cents if you use the incorrect value, and that's not good. Depending on, for example, if you're working on a financial system, you don't want to use. You want to make sure you don't use integers for dollars, just because people end up losing a lot of money. Okay, and then after that, we need a way to represent true false. So we have the notion of Boolean. And for Booleans are only really represent true, false, and in some languages 0-1. And then lastly, we have char, which is a way of representing individual characters of some encoding. I believe Java has specific, but we'll look into that. So these are the types that we work with in Java, and we can do some really complex things with these types. Okay, so now let's move away from that. So for our application, since we're dealing with, I want to build a booktube application, right? I would say at the base level, I want to be able to represent a book. So going back to the definition of an object, where we want to create a book object. And this book object, I want it to essentially contain book info. Like what we basically have to define what a book is, and we'll start to understand just how powerful these base types and the notion of an object really are. So in this space over here, let's define what a book is. Okay, so what is a book? So I'm going to use a representation of the data that we're going to use for quite some time, but I want you to understand that I'm introducing something called JSON, which is a way of storing information in a readable human format. You can essentially encode, so you can encode and decode an object into JSON. So what is JSON? So let's take our book example. Let's zoom in a little bit here. Let's take our book example, okay? So what is a book? So when we think about what a book is, a book has an author. Or a title. Let's start very, very basic. So we know a book has an author, right? So when you're representing data in JSON, you want these to be strings, or you can think of strings as a collection / list of characters. Right, remember what a character was. Fun fact, so characters are actually converted to some numerical value because computers don't really understand what a character is. Computers mostly communicate with zeros and ones. So you have to represent that all of this data in 0 and 1s, which is why like two complements comes in, because for a given amount of data, you can represent only so much information. So yeah, and you can only store so much in a chunk of memory, right? So you can start off with 4 zeros, and you can represent a lot of different numbers in different combinations. Yeah. We'll talk about how to do this math and how to count in binary. So this is binary. The way you can think about it is that when we're young, we're taught to count from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Well, 8, 9. Um, and all we're doing is working in base 10. And computers, and you'll see the similarity here. Computers only work in base 2. Okay, so we can do this. Computers can do this, or we normally count in this, and computers count in this. But you can represent. There's a mathematical proof to show that you can represent all numbers in all the bases, but we won't get into that. So back to what a book is. So a book contains an author, right? So we'll just name them some author. Some author. After that, we know a book has a title. And after that, we know a book also has the number of pages. Say 450. And let's actually make something really interesting. So all books in the world have a certain number of people who are reading that book. So when we think about the application that we're building, let's track that. So let's track number. Let's track number of readers, right? And this will be some value. So let's say for our book, there are 1,000 different people reading this book at one time. Okay. And we'll figure out how we can calculate this number, right? Because all of these values are static values, and all of these, this number is a number we would have to really calculate on the fly somehow, and that's where the problem becomes interesting, because how do you store that information, right? Let's say there are a couple billion people reading a book right now, reading something, right? A couple billion people reading a book, right? How do you, in real time, get how many people are reading this particular book? And then you do that for all the number of books in the world, right? It becomes a very, very interesting problem. And you can see we can represent that problem using just these basic types and the notion of an object that encapsulates all of these types. And you know what? Let's get a little bit more interesting before we go into the code. So we know what a book is, right? But authors, you can get really specific about authors. So let's also represent an author. Authors are human beings who write books, right? And they themselves have information or have data that represents who they are. For example, authors have names. Authors also have, let's say, their favorite book. Ooh, yeah. Let's get interesting. So yeah, authors have a favorite book, and here you would put another JSON object that represented a book, right? Because, well, all you're doing essentially is saying that they have a favorite book, and you want to put a book there. And I'll show you what that looks like in the code. And all you'll do is, and you can do this relationship because nobody's inheriting anything. Authors and books are not related. If they were related, there are some things that we can and cannot do. But again, that's like the hierarchy, right? And like the classic examples, um, animals and like cats. Like cats are animals, but not all animals are cats, right? That's a very hierarchical relationship, so we can't go backwards in the hierarchy, or we can't go, yeah, we can't really go backwards. And by backwards, I mean like not all animals are cats, you know. Um, but in this kind of relationship, it's possible for authors to like books and books to have authors. So they're two very different pieces of data, but we can nest them like this. So a favorite book, and let's say just for purposes of this, let's just add dot dot dot, and then another dot dot dot, and then let's say title, favorite, book, right? And authors also have, let's say, their location, right? Authors live somewhere or write somewhere, right? And let's say this location, let's just say it's a string for now. And then we'll see what we can do with this information, right? So we've now represented two very complex things. So for the number of, so going back to this, so we're using a collection of characters or strings. Strings help us represent words. Then you have a title, which is also a string. Then you have the number of pages, which I'm using to represent it as an integer, because going back to this, right, you can't really, I guess this, so you could technically use a short, but the standard is really to use an integer. Just because, let's say we didn't just want to represent like a book, let's say we wanted it to be something larger than a book, but we still called it a book. We're safeguarded by the integer. The long we also don't really use because it stores a lot of memory. So let's just stick with the integer. And then floats and doubles, we're not dealing with any decimal values. For location, if we were dealing with lat longs or latitude, longitude, let's say our location was a pair of latitude if I introduce a pair, I have to introduce what a pair is. So yeah, let's just call it that one. Okay. So yeah, let's just call it a pair of lat long. So those we would represent them as doubles, and then we have our chars, which are strings. Okay, so we have these two objects. So let's go to the code and see what the code looks like. Okay, so let's take a look at the code representation for what we just represented in a Scala draw. So what I have here are two objects, which are classes. And the first one is an author. So we talked about an author as having a name, a location, and a favorite book. And what I've done here is I've overloaded the toString method, because what we know is that every object has a toString. So you can override that toString, let's see here, right? Because at the core, every object that you create in Java is an object. And because it is an object, it contains all of the methods, all of these public methods. For example, we can overload and create our own equals. Like, how do you equate two authors? How do you equate two books? And you can go in and read this and read what the toString does. So if we go to toString, you'll see that it returns a string representation of the object. So for an author, what we've done is represent the author as a name, a location, and and having a favorite book. And now if we go, and you see I've added these annotations here, the getter and the setter, which creates code for us that allows us to get the object and set the object values. Here we're calling the builder that will allow us to build this object, and then the allargs constructor, which is essentially what happens is that when you create an object, you get a constructor out of the box, and this is the base constructor, but then you have an allargs constructor that consists of the name, location, and the favorite book. And to shorthand it, it looks something like this. So this is just a one argument constructor, but we want to have an all argument. So you can see that it will contain both a name, a location, and a favorite book. Okay, then let's deep dive into what a book is. So a book will have the title, the author, the number of pages, this value that we introduced, the number of readers, and its own constructor of 3 arguments. So we can construct a book with just a title, an author, and the number of pages. And then after that, we have the toString representation of the book. And you can see I have the same annotations here, the getter, the setter, the builder, and the allargs constructor. And then here, I pulled a couple of books from my bookshelf. And what I've done is I've gone ahead using our notion of very basic types and the objects that we created to represent these objects in the computer. So you'll see here, I have Artemis Fowl, and I'm building the book, and the book has a title, and the book also has the number of pages, for example. And this book has 342 pages. Okay. Then we have the author, Madeline Miller, who has the name Madeline Miller, who lives in Narberth, Pennsylvania, whose favorite book is Artemis Fowl. So we pass in the Artemis Fowl object that we created. And then you build that Artemis Fowl object, or the Madeline Miller object. Then we have the book that she wrote, which is Circe. And we can represent that book with the title Circe, the author Madeline Miller, the number of pages for that book as well. And when we print that out and run the application, we'll see that this is the author Madeline Miller, whose favorite book is Artemis Fowl. And you'll see, let's wrap this up also in maybe parentheses as well. Okay, to make it a little bit easier to see. So the name Madeline Miller, whose favorite book is Artemis Fowl, who doesn't have an author because we didn't specify an author, but we could very quickly represent that author here by setting the author and then author.builder.build, and then let's just do name and Colfer, and then the let's say they don't have a favorite book, and let's say they do have a favorite book, but we don't have to add that information right now. And then the location, readers will be able to see the location here. I don't see a location, so we can also leave that blank. Okay, and then cool. And that is how we well, that is how we represent our book. And let's actually take a look at this very quickly to see what is being represented and how it's being represented. So let's use our tool and debug. So we can see we have Artemis file, which is a book, and that book has a title, an author, a number of pages, and 0 readers right now. If we go to the next one, we see we have Madeline Miller, who has a name, a location, and a favorite book. And that favorite book is Artemis Fowl, who has an author, etc., etc., etc. So that's how we can actually get a view of the book that we of the books that we created before they're printed. So that is how we represent all of that information. Let's say we wanted to add some information. We could say that an author has a collection of books that they've written. Okay? And we'll need to import this. There we go. So every author will have a list of books written. And yeah, I think that's all for now. Oh, and you know what? For sake of argument, we'll create a reader. And for now, that reader is very basic. And the reader has a name. And they have the book. So current book that they're reading. So we'll put a comment here. And then we'll say that every reader has a favorite author. And then we'll do our annotations. And we'll leave it there for now. Awesome. So yeah, I think we've covered a lot of ground today. And you can see that we've represented some very complex ideas with all of this information. And we'll talk about how we'll use these complex ideas. Maybe we can store them somewhere and access them, and then go back to using our API and building that out. Thank you very much.